Good morning and welcome back to Pre-Algebra with Miss Betsy. We're continuing on today with our study of integers, and we are in section 4.2 where we're talking about adding integers. As our text, we are using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. Follow along with us beginning on page 115, or use any other standard Pre-Algebra textbook. You'll find that the material that we cover today is not limited or bounded in any way by the fact that I'm using a specific text. Before I get started, of course, we have our lame joke for the day. Today it would be, what do you call something that weighs 5,000 pounds and wears glass slippers? Well, of course, that one's name is Cinderelephant. So, talking about adding integers. And we're getting just a little bit of theory today, and I know people hate the word theory, but it's the underpinnings of what lets us add positive and negative numbers together. And we're going to just illustrate something by adding integers on a number line. And what I put up here to begin with is just an illustration, or just an explanation of how we actually add those numbers on a number line. And what we're going to do is we're going to indicate adding a positive integer by showing an arrow going towards the right. And if we're adding a negative integer, we're going to show that we have an arrow going towards the left. So as soon as I finish drawing this little number line, up here we'll go ahead and get started. We remember that we've said that on a number line we have positive numbers to the right, negative numbers to the left on the number line, and the further you go in the right direction, the larger the number gets. The further you go towards the left, or towards the negative number, the smaller the number gets. So this was a hard concept when you first began to understand it, that minus 9 million is smaller than 0. But you understand that now, and you have a good visual of that, because negative 9 million is much further to the left on the number line than 0. And the further to the left on the number line that you get, the smaller the number actually is. So what we see on page 115, it says, you can use a number line to illustrate adding integers. To indicate the addition of a positive integer, we're going to have an arrow that goes to the right. To indicate addition of a negative integer, we're going to have an arrow that goes to the left. So let's see what happens if we add together a negative 1 and a negative 4. We're talking about the sum of negative 1 and negative 4. And once again, that's vocabulary there. So I'm on page 116, and we're going to start at 0 on the number line, and we want to add together a negative 1 and a negative 4. So we're going to start right here at 0. And how are we going to indicate that we're adding a negative 1? Well, it says with a negative number, negative integer, you move to the left 1 unit. So this is 1 unit to the left. And that's how we indicate our negative 1. Now, we want to add to this a negative 4. We say that we're going to add a negative integer by moving left on the number line. And let me go ahead and add a couple of more integers here, because we already know that negative 1 and a negative 4 is equal to a negative 5. So we're starting here, and we're going to go 4 units to the left. 1, 2, 3, 4. So what this illustration is showing us right here, of course, we end up at negative 5. So negative 1 plus a negative 4 is equal to a -5. We began at 0, we added a -1, which means that we're going to move 1 unit to the left on the number line. Then we added a -4, which means we go with our starting place, which is now -1. And we move 1, 2, 3, 4 more units to the left on the number line. And we see that we have ended up at a -5. So what you're seeing here in a box, this is what they say. This, see right above it, this says, notice that the sum of two negative integers has the same sign as both of the addends. We're adding together a -1 and a -5. A -1 and a -4 to get a -5. Move 1 unit to the left, 4 more units to the left, for a total of 5 units to the left of 0 on the number line, which is where that negative comes from. So we're adding these integers together. They both have a negative sign. Their sum is also negative. So what this is illustrating to us is that when we are going to add integers together, if they have the same signs, what you can do is you can add their absolute values together, but you can keep the sign of the original numbers. Okay, that gets a little bit strange sounding when they're talking about adding together their absolute values. But remember, last video we talked about absolute value, and we said that all that absolute value is that it's the distance a number is from 0 on the number line. How many units away from 0 is this? Well, that's 1 unit. How many units do we have from -1 to a -5? Well, we have 4 units, so we can actually say, if we want to add together a -1 plus a -4, we can just add their absolute values together. And I'm going to go ahead and erase this. I'm having a little bit of difficulty staying within the bounds of my video here. Video camera. Let's make a new number. We have -2 plus a -1. And what we just said, I read from the rule in your book that says if we're going to add together two integers that have like signs, what we do is we add together the absolute value of those numbers. What's the absolute value of -2? It's a 2. What's the absolute value of a -1? It's +1. We add together their absolute values. Are we finished? No. Then we use the sign, the original sign of those numbers. And this is what you're always going to do when you add together integers that have the same sign. It doesn't matter if they're two positive integers that you're adding, two negative integers. This is when you add like signed integers. First, you add their absolute values. And that's what we did in this problem. We said that we had a -2 and a -1 that we wanted to add together. The very first thing we do is we add their absolute values. Absolute value of -2 plus the absolute value of -1 becomes 2 plus 1, because absolute value is just distance. Distance is never negative. Distance is always positive. So first, we added together their absolute values, and we came up with a sum of 3. But then the second part is equally important. And the way they say it in your book is write the sign of the add-ins in the sum. Use the same sign. Write the sign of the add-ins in the sum. So what is this saying to do? 2 steps here. Let's review them. If we want to add like-signed integers, first we want to add together their absolute value. Here's our original problem, -2 plus a -1. The signs of those integers are the same, they're both negatives. First we're going to add their absolute values. Absolute value of -2 plus the absolute value of -1. What is the absolute value? Absolute value is distance from 0. It's always positive. We have 2 plus 1. What is the sum that we end up with? We end up with 3. But this is not the answer. You get a different color marker here. Not the answer. Why is that not the answer? Because we've only completed part of the problem, part of the instructions. It says add together their absolute values, which we've done. But then, because we're dealing with integers, which are signed numbers, you have to say, is this supposed to be a positive 3? Or is it supposed to be a negative 3? And the way you determine that is you look back at your original problem and you look at the sign of those add-ins. Remember, add-ins are what you add together. Sum is the result, is the solution to an addition problem. Because the sign of the add-ins in this problem is a negative, the answer is negative. And I think maybe, I'm hopeful that we already understand how to do this, how to work this out in practice. This is why it works. This is the method that you would use. You do not have to be using, drawing the addition of signed numbers on a number line. They just want you to understand that that's what's going on. Let me do this one right here. -3 plus a -4. We're adding together integers. They have the same sign. When you add together integers, you can add together their absolute value. You do not have to write this step. Once you understand what you're doing, the absolute value of -3 plus the absolute value of -4, 3 plus 4, their sum is 7. What we've done is we've added together the absolute values. The second part says go back to the problem and say what is the sign of the add-ins, and use that sign. -3 plus a -4 is a -7. And that same method of addition works for just the addition of 2 positive numbers. You already know the 3 plus 4 is 7, but because these are integers, they're positive things, you can think of that as being the absolute value of 3 plus the absolute value of 4, which gets us right back to what we have to begin with, which is 3 plus 4, 7. We keep the sign of the original add-ins in the problem, which is a positive sign. So you see that even though we don't use the fact that we're adding together opposites and keeping the sign, when we're adding together positive numbers, we see that you can actually do it that way. Now, what happens if we are adding together 2 numbers of different signs? So let me find one other than what they have in the book here, because I really don't like it. We'll do problem number 4, which is a negative 6 plus 2. Actually, I'm going to make one up. We're going to say a negative 4 plus 3. Let's go ahead and look at our number line. So I have 0, 1, 2, 3, negative 1, negative 2, negative 3, and negative 4. And we're going to remember, what did it say we can do when we're adding together integers on the number line? When we add a negative, we move to the left. We add a positive, we move to the right. We're going to start with 0. We're going to add a negative 4, so we're going to move 1, 2, 3, 4 units to the left on the number line. And that indicates that we have added a negative 4. If we want to add 3, what do? We move from the point that we're at, right here is negative 4, and we move 3 units to the right on the number line. And where do we end up with? When we have our arrow going back 3 units towards the right, we're adding 3. We end up with, graphically, negative 4 plus 3 is equal to a negative 1. We started at 0. First we moved 4 units backwards. 1, 2, 3, 4. Then we moved 3 units forward by adding 3. 1, 2, 3. We ended up with a negative 1. So now, this is the undergirding theory that lets us know how to add together integers that are different signs. And this is the method that we have been using. I want to go ahead and write the definition from your book for you. Or write the method that you use from your book. It says, what do we do if we're going to add integers that have unlike signs? I'm going to put this over here. Unlike signs. What did we do first if we were adding integers that had like signs? Well, what you did was you added the absolute value of the addends. What we're going to do here is we're going to find the difference of the absolute value. We found the sum difference. We found the sum when we were adding like signed integers. When we were adding unlike signed integers, we have to find the difference of the absolute values of the addends. And what is it that we're talking about when we talk about difference? In a mathematical sense, difference is the answer to a subtraction problem. So, we have negative 5 plus 2. They want us to find the difference of the absolute value. Absolute value of negative 5 minus the absolute value of 2. 5 minus 2. This is the first step. We want to find the difference of the absolute values, and they want us to subtract normally. You subtract the smaller number from the larger number. The smaller absolute value from the larger number is what we're doing in our first step. We're finding the difference of the absolute values of the addends. And I totally wrote some weird word there. Okay, what's our second step? Our second step says write the sign of the integer with the greater absolute value. Sign of the integer with the greater absolute value. We look at these two integers. We have a -5, we have a +2. We find their absolute values. Which one of these has the greater absolute value? Yeah, of course the 5 has the greater absolute value. So what do? We use the sign of the integer that has the greater absolute value. This integer had the greater absolute value, so our solution to -2, -5 plus 2 becomes a -3. Because what we have done first is we have found the absolute value of our two addends. We have taken the difference of their absolute value. We've, in essence, ignored the sign and subtracted the little number from the big number. Well, I'm not speaking technically correctly. You understand what I'm talking about. We subtract the smaller number from the larger number, but then because we're dealing with signed numbers, we have to say, okay, which one do we subtract from which sign do we use? We look for the sign of the integer that has the greater absolute value. 5, obviously, is greater than 2, so we're going to use the sign that goes along with the -5, giving us a sum of a -3. I would like to do one more of those for you. Let's do -16 plus 7. Let's do 7 plus a -16. We want to find their absolute values. Absolute value plus the absolute value of a -16. What's this going to be? Absolute value of 7 is 7. Absolute value of -16 is -16. So what do we do now? We're going to subtract. We're going to find the difference of their absolute values. We're going to change the direction there, which you automatically do, but you have to think. We're not going to say 7 minus 16. We're saying 16 minus 7 is 9. Now we want to see, are we using a positive or a negative? Is our solution positive or negative? Look at our two original addends. -16 has the larger absolute value, so we use the sign that has the larger absolute value, and our sum of 7 and the -16 is a -9. Okay? The last thing that we talk about is the opposites property of addition. This says that anytime you add a number and its opposite, you always end up with 0. For every integer a plus the opposite of a is equal to 0. For every integer a plus the opposite of a is equal to 0. And this is what they call the opposite property, opposites, of integers. And you'll need to be able to say that whatever that value is, whatever that integer is, if you take a number and its opposite located the same number of units from 0 on the number line, and you add those together, you're always going to get 0. Let's say that we have -2 plus 2. We start at 0. We go 2 units to the left on the number line. Then we move 2 units to the right on the number line, and you're back at 0. A number and its opposite, the sum of those is always equal to 0. Well, what if we had 2 plus a negative 2? 2 on the number line is 2 units to the right, plus a negative 2, 2 units to the left. And we still see that the sum of a number and its opposite is always equal to 0 on the number line. That's the end of section 4.2. I think you'll do a great job with it, and I'll see you next time.